Hello, welcome to my channel. I'm Amaya, and in previous video we talked about tracking devices, the types of tracking devices, and we started with motion trackers. In this video we will be discussing about magnetic tracking and the mechanical tracking. Starting with magnetic trackers use a transmitting device that emits a low frequency magnetic field. A system in this figure is basically a low range magnetic tracking system which will have a sensors and receivers. Generally, the range of these devices will come in between 4 feet to 30 feet, so it is not used or not appropriate for large display environments. It is generally used for the smaller displays, conventional monitors, and small workbench displays where the range of devices is not a critical factor. A system will generally have a small sensor, the receiver, which determines its position and orientation relative to its magnetic source. The magnetic tracking systems are accurate to within zero point 0.1 inches in position and zero point 0.1 degrees in the orientation. As the system works on the magnetic field, the disadvantage of that system is that any ferromagnetic or conductive object present, like a metal pieces or metal objects present in the room with the transmitter, will distort the magnetic field. Once that magnetic field is distorted, is basically affecting your accuracy. Sometimes these accuracy reductions can be very severe, which is making these interaction techniques, especially gesture-based techniques, difficult to use. Now there are ways to avoid or the clear out these distortions. Either it can be done by calibration routines or it can be done by the filtering algorithms, which will remove excess or the noise signals which are generated in this system. But these calibration routines or filtering algorithm will increase the startup time and online computational overhead. So definitely it will take more time to get the data from the magnetic tracking system. This is about the magnetic tracking system. Now let us move towards the mechanical tracking system. Now compared to magnetic tracking system, the mechanical tracking system is comparatively easy. Mechanical trackers have rigid structures with number of interconnected mechanical linkages combines with the electromechanical transducer such as potentiometers or shaft encoders, which will give values of positions and the movement of that mechanical tracking system. Generally, system will look something like this, which will have multiple linkages, which will basically look bulky, large systems to track a data. One end of this system will be generally fixed, and end is attached to the object to be traced. That object can be head-mounted display, user's head, or a user's hand, and you will be basically tracking motion of that head or the motion of a hand of a user. Now, mechanical trackers are considered to be very accurate and transmit information at with very low latencies. As the tracked object moves, the linkages moves as well, and the measurements are taken from the transducers to obtain position and orientation information. The disadvantage of these trackers are often bulky, limiting the motion of the motions or users' mobility because it is connected to the some fixed support and it is connected through the wires, making it difficult for the use of physically based navigation techniques which are used in environments. These are the advantages or use of the mechanical tracking system. That's all about this video. If you like this content, do subscribe my channel and keep following this playlist for more videos on VR in automobiles. Thank you for joining.